In this section, we will be going into more depth about elastic collisions. An elastic collision is one in which both kinetic energy and momentum are conserved, such as two pool balls colliding. The top equation is an illustration of the conservation of energy, kinetic energy, where we have the kinetic energy of mass A plus the kinetic energy of mass B before collision equals their combined kinetic energies after collision. The second equation illustrates the conservation of momentum, where we have the momentum before collision is equal to the momentum after collision. Here is a special case of elastic collisions with one body initially at rest. We start off and write our expressions for conservation of kinetic energy and conservation of momentum as seen under the one body initially at rest. I take my expression for the conservation of kinetic energy and I simplify it. I divide through by a half, and I put like terms on each side, and I get the mass of B times the velocity final of B squared equals the mass of A times the velocity initial of A squared minus the velocity of A final squared. I take that side of the equation and FOIL it out, and I get the right side of the equation is going to equal the mass of A times velocity of A initial minus velocity of A final times velocity of A initial plus velocity of A final. Then I take equation for the conservation of momentum and rearrange the terms. And I rearrange the terms so it reads the mass of the body B times the velocity final of B equals the mass of A times velocity initial A minus the velocity final A. Next, I'm going to divide one equation by the other. I have taken the conservation of kinetic energy equation divided by the conservation of momentum equation, and I get the velocity of B final equals the velocity of A initial plus the velocity of A final. My next step is to take my expression for velocity of B final and substitute it back into my momentum equation. Distributing my masses and solving for VF gives me VAF equals mass A minus mass B divided by mass A plus mass B times VA initial. And finally, substituting this expression back into my expression for conservation of momentum gives me the final equation that I will show you on the next slide. And here is our final equation for an elastic collision with one body initially at rest. The velocity of the second body B final equals 2 times mass A over mass A plus mass B times the initial velocity of mass A. Another interesting thing happens when the masses that are colliding are equal. If mass A equals mass B, then mass A will give all its velocity to mass B and it will end up at rest. And you can see the math here proves that. So if MA equals MB in the denominator, you have velocity final of B is going to equal to the initial velocity of A.